It's easy to get excited and happy at the moment, thinking everything's going well, it's a success. But I have to keep reminding everybody, yeah, it's good news so far, but we're only part way through the journey.
Copy that, main pole stop.
Yeah, no problem.
The real overall objective is to understand subduction plate boundary earthquakes. We know that earthquakes seem to occur or nucleate in a particular depth range, but we don't really understand why that is. Is there something specific about the rocks that are there? Is it something about the physical conditions, the temperature, the stresses, the pressures? And so that's what this expedition is all about, is installing one of what ultimately will be a series of 2 or 3 borehole observatories that penetrate into the fault zones or in the near field of these fault zones to get that kind of time series, or the pulse, to take the pulse of the earthquake fault.
So the plate boundary is preparing for the next large earthquake. So to identify the areas of the rupture in the next earthquake is key to assess how large tsunami is associated with the next large earthquake.
We're happy now, all the sensors seem to be alive and healthy and well, but it's a big challenge to go from atmospheric pressure and dry into the ocean and then down to high pressure. And so the biggest challenge at the moment will be very carefully and successfully lowering the equipment through the water column while the ship is moving and in a relatively strong ocean current. So we need to survive that whole trip. And then, of course, once we get down to the bottom, a second big challenge is going to be re-entering the borehole, and again doing so carefully and gently enough that nothing is damaged. And we'll all breathe a big sigh of relief at that point.
Oh yeah, oh yeah, oh yeah. It's logging, right?
Yeah. Okay, so we're going to download first, and then we'll save the metadata and everything.
Yep.
Yep. Okay. We're happy?
I think
Say
so.
goodbye. All right.
Say goodbye for the next 10 years.
Okay, bye-bye. See you later.
See you.
Is it okay for you?
Yeah, yeah, they can come down, stand by, we're going to go up to, I'll be talking to draw 4.
Hi, thank you.
Sean gave me a call about 20 minutes ago to come up here and confirm the location of our coring hole. This is the observatory hole here, and you can see, but these contours are 10 meters apart. And so we're actually going to start the new hole 20 meters or a little bit more than 20 meters to the southwest of the previous hole to make sure that we are close enough that the geology is similar or almost the same, but far enough away that we don't risk the possibility of intersecting with the observatory hole. Right now, We are slightly ahead of schedule according to the operations time estimates, and that actually is one of the other really exciting things about being at sea is the unexpected provides a level of excitement and the possibility of doing something new and different. And in our case, we have the possibility, if we have extra time, we might be able to core, we might be able to drill and sample the rocks in the exact same place where we're installing these instruments, and that will allow a whole new suite of experiments and measurements to be made that will be highly relevant to the observatory installation.
Looks like we got a little bit of a fault captured in the core liner, so we'll get a better sense when we look at it with the CT scanner.
They're not drilling in these. Right.
Well, the reality is that this expedition has only just begun, especially in terms of the science, and that is directly related to all the core we collected, which still remains to be analyzed, sampled, and that all will take place long after the ship returns to harbor, to port. But as far as the observatory goes, it's only the beginning. The science will be just starting all over again.
So next step is to connect the observatory to the network, seafloor network called DoNet. So once the observatory is connected, we can compare these observation data in real time, which is really exciting.
On what's happening, I think everybody knows. And of course, this is used both for scientific purposes, but also as a hazard mitigation system. This is an early warning system. One of the other amazing things about this expedition is not just what we have achieved for the Nankai Trough, but this also provides a template for studying earthquakes and tsunami hazards at other margins, like the Pacific Northwest of the US, the Alaska margin, South America, New Zealand, and many others. In a sense, it's a step toward a global understanding of subduction zone earthquakes and tsunami hazards rather than a very specific focus in one area.
The nucleation of earthquakes is something which is an interplay between physical and chemical processes. This is why we need IODP to actually look into that, because we need the best minds from different nations and different disciplines to come together, engineers to help us to put observatories together in order to unravel earthquake nucleation.